Hi, good afternoon, guys. Welcome. It's a funny time of the day. I'm used to being up either early in the morning or late in the evening, so yeah, this is quite fun. Today we're going to be looking at plumbing planning for new builds. When we're saying planning, it is planning from a design point, or let's call it planning from a design point of view. This is just for information's sake, so that when plumbers do get plans to quote on or work to look at, that they are aware of what is supposed to be on that actual layout. So let's get into this. When we're looking at a licensed or qualified plumber, or a plumber looking at doing work, there are a number of factors that needs to be taken into account. Stresses and pressures that are being applied from all over. For argument's sake, we're looking at, I put that on top because that is where the control, or that falls in the area of um, the final closeout of that project. But in the meantime, the plumber's got to worry about labor, money, time, the owner, material, all kinds of other things. So the one thing that you do not notice on that list is paperwork. We're all familiar with this little slide or meme, whatever you want to call it. The job is not done until the paperwork is done. I would like to change that. And I would like for plumbers out there, the guys that are enjoying the session or that are listening to the session, to change their approach. We should rather have a look at work that says the job should not be done without paperwork. I mean, if you had to run into a stall and you looked at that, you would turn around and walk away. The same thing should apply to any work that does not, if it doesn't feel right, 9 out of 10 times it isn't. Before I get into the actual plan requirements, you would have seen this thing a number of times before on some of my presentations. Let's call this the level of authorities. We've got overarching legislation, the Health and Safety Act and the Consumer Protection Act, which basically covers everything else. Then we have the actual legislation, the acts, the National Building Regulations and Standards Act. Particular interest to the plumber would be A for admin, B structural, L for roofs, P for drainage, R for stormwater, S for people with disabilities, W for fire, and XA for energy efficiency. That would be, or those would be the ones that actually stand out when it comes to doing the National Building Regulations. And then you'll find on the same level the Water Services Act of 1997. So below that, the applications of building regulations 10400, 10252 Part 1, Part 2, and 10254. These are the application of those various regulations. Water Services Act would be the act, and the application of the regulation would be these two water issues over here. Then there's installation standards, and this is where today's presentation starts off on this level here. It includes or incorporates other documents, but this is where we are as far as today is concerned. We're looking at building control and water service authorities, in other words, municipal bylaws. And then we're looking at licensed or qualified plumbers doing work, doing their own sign-off prior to giving or calling in the building control officers. So you'll see I put this in here on purpose. We're not here to start a fight with the local authority or the building control officer, because I can guarantee you that's one you're not going to win lightly or very easily. So we'd rather come in peace, and we see that there are some common grounds and there's benefit for both parties in working together. So two sets of building plans, or two aspects to submitting a building plan. The first one's water. Let's look at water, and let's settle something very early on. Every other week or every other day, you hear people talking about, you know what, water is not in the building regulations, only fire. Or the building control is not worried about the water installation on a building because, you know what, that is not, it doesn't form part of their very important National Building Regulations and Standards Act. In that same SANS 10400 Part A under the admin, you'll see, although this falls under the informative section, it is very clear that says the Water Services Act enables the Minister of Water Affairs to prescribe compulsory national standards, not nice to have or not this way or that way. It is a compulsory national standard relating to consumer installations, and in this regard it defines a consumer as any end user who receives water services from a water services institution, including up to an informal settlement. And a consumer installation, which is what we be busy with, is a pipeline, fitting or apparatus installed or used by a consumer to gain access to water services, and it includes a meter attached to that pipeline, fitting or apparatus. Now, we saw that the Water Services Act and the National Building Regulations Act is the same or is on the same level. So Regulation 14 of R509, published on the 8th of June 2001, issued in terms of that Water Services Act, reads as follows. Consumer installations other than meters. Every consumer installation must comply with 10252 Part 1, the water supply and drainage for building, and SANS 10254, the installation, maintenance and repair of fixed electric storage water heating systems, or any other similar substituting, reenactment or amendment thereof if the consumer installation is of a type regulated by either standard. Whole long story, whether it's an old one or a new one or the current one or previous one, those two documents that you see over here are applicable to every single consumer installation out there. Then it carries on to say that the National Building Regulations do not contain any provisions that relate to water installations in buildings other than those pertaining to fire. Therefore, consumer installations are regulated by 10252 Part 1 and 10254. 10252 Part 1 establishes general principles for the design, installation and testing of water. So today's session is around the actual design. There are requirements, and it is something that when I spoke to Steve about actually doing this presentation, this session is in order for the plumbers out there that when you see a building plan or when you see something that you need to quote on, is that you need to make sure that this document, if it hasn't got stamps on it or it doesn't have a note on it to say that it's been approved, please revisit or please confirm with whoever your client is that this thing is indeed approved, and then that would be your starting point. If there's any dispute, for the guys that remember, we did the TAC resolution around rational designs and that. Once you've actually notified your client, whether it be the owner of the building, the developer or the builder or the architect, or the local authority for that matter, once you've notified them that there's a problem with the design or doing the work as per the design is going to end up in being a non-compliance and it wouldn't be able to be signed off, then that notice forms part of your COC that you'll sign at the end, but you have to do that up front. It's not once the building inspector gets there and he fails the job, or the water and sanitation have got plumbing and drainage inspectors in some local authorities. That's not the time to go hunting for a design. So if we look at water, initial design considerations, straightforward. The following information as necessary shall be obtained from the owner of the premises or from the water supply authority or the designer. Take note, there's no plumber there. You're more than welcome to assist, or you'll probably get contacted if you're one of the more senior guys in the group or in the session. You'll find that this would be approached by the client or by an architect for some help or some designer for help. But notice there's no plumber included in the standard. Says that these three people will be responsible for that design. Included in that design will be a plan of the site showing contours, proposed existing floor or terrace levels, all related to a geodetic datum, and the location and description of any services on site. Why would that be important as far as our plumbing is concerned? For every 10 meters of elevation, you're losing more or less 100 kPa in pressure. So if it says existing floor or terrace levels, if you're looking at 10 stories at plus minus 227, let's call it 3 meters, it's 30 meters. So 30 meters, you'll see it's got quite a considerable impact on your actual water supply. So when it comes to a design, then obviously that is a bit of an issue. So the requirement is for level or for levels all round. The intended function of the premises and the types of activities to be carried out on the premises. In other words, is it a normal residential H4 dwelling? You'll see paper milling, industrial cleaning, textile, dyeing, whether it's manufacturing or dyeing, the volumes and the actual supply quality or the pressures and that all accounted for. C says you need a drawing of the building showing the points that require water and the proposed type of sanitary fixtures that go in there. So if you look at this layout, you'll see it's very clear. So now when you look at the plan as a plumber, and that's what most of the council guys do. Oh yes, I can take that waste pipe out there, that's outside. So that could be done quite easily, as opposed to some other designs that we'll have a look at a bit later on. Bigger building. I say bigger buildings, normally the more upmarket buildings or the more expensive buildings, there's a schedule of sanitary fixtures and apparatus that require water supply. What makes this very nice is that when this thing comes out, whether it be in the form of a bill or whether it be as an attachment or one of the sheets on that building plan that was submitted, this is the perfect opportunity to actually look at a product, look at the code, and when you're quoting on this thing and it says it's got some name here that you can't pronounce or you're not sure about this, you can get a little mark there or question mark there, and then when you do go through this list to price, you make sure, oh yeah, this is a compliant product, oh yeah, that's a compliant product. So those ones that you can use, you can actually tick the ones that you've got a query on early on, even before you bought the material. E says you need to have the design population of the premises and the times that the premises will be occupied. That's to do with water consumption, energy efficiency, just all-round supply as far as the design is concerned. See, in this case, this is different tables from various documents. So you'll see H1, I picked H1, as a hotel occupancy where persons rent furnished rooms not being dwelling units. So you'll see H4 is a normal house, but H1 is the one we're looking at now. And you'll see the design population for H1 is 2 people per bedroom. You'll find most hotels have got double beds in them, so you design for 2 people per bedroom. And that design occupancy time for H1 is then 24/7, because you've got people cleaning, staying over, coming in late, coming in early. So they are busy 24/7, or they're being occupied 24/7. So that's for E. The quantity of water and the water pressures required. We looked at that industrial cleaning bit earlier on. If you're only having a normal single residence, it's not as big an issue as what you would for a 10, 15 story hotel or a dormitory for kids at a varsity. So we need to know the quantity. Sorry, we being the plumber needs to know this from building plan submission. That needs to be sorted out between the client and the designer. The nature and the subsoil on site, for the guys that have attended that 10.252 part 1 sessions before, you'll know that copper you can't put into ash or anything salt or ammonia. You're looking at PVC pipes and heaving clay. There are various types of restrictions on what material could be used in which areas. So that would be part of the design. And then the quality of water obtainable from the suppliers. Okay, guys, this is a difficult one. I could have put a normal glass of water there. So instead of doing that, if we have a look at this table quickly, you have raw water that being in your dams and rivers, and they get, or that catchment area then gets piped or gravitates down to where they do the screening. In other words, you get rid of all the fish and the branches and leaves and all the bigger stuff. Then you add coagulant. It looks like the ones that we normally use are the ones that look like a purple color salt, and you throw those crystals in there, and as the little bits of particles and dirt attached to that, you'll see they go and they settle down in the bottom of the sedimentation tank, and then they go through this whole process of filtration, different types of filtration in different areas for different local authorities or water supply authorities, but they basically work on the same principle. And then they do the pH correction, they do the anti-corrosion agents to make sure that your plumbing doesn't get eaten away, and then the chlorination, and that's how it ends up at your house. So when it comes to quality of water obtainable, all of these processes differ from region to region, from water supply to water supply authority. So if you have a hard water area, or you do have water that's been treated up to this point and very little done in this area or done differently to other areas, obviously the local authority would be able to advise you on that, the quality of their water. Should be SANS 241. Part 1 and 2 compliant, but best is to just confirm with the area. Once you've worked in the area for a certain amount of time, you know what you're up against as opposed to some other areas. The static and, where possible, residual pressure in the water supply mains. So static being what is available to you, and residual being that once the design has been done or the pipe sizing and fittings and all the rest have been done, whatever remains in that installation, that would be your residual pressure. So you could have that. Water quantities and flow rates obtainable from the water supply main from the various types of, for the various types of water demand. So if you had to build a house on the left-hand side here, and that's the supply main in the street, you know you're not going to have a hassle as far as getting water to your premises is concerned. Okay, so a bit of homework to be done between the designer and the owner. Schedule of acceptable pipes and water fittings and the size of the water meter. Requirements for drawings and other information that has to be submitted in order to obtain approval. Any special precautions to be taken for the crossing of other services on the premises, and details of existing connections and services. Straightforward enough. Okay. Part L says, or section L says, the location of the point of connection to the water supply main or of the communication pipe. So if your client happened to be the one with a little star in that, you'll see that the water main is actually on the verge in front of your client's property, and it'll be left front. So if you had to start digging or you had to start your design, that would be the point available from your local authority on their system. Most of them have got these points. You'll see in this case, this one shows isolating valves as well, so that if a portion needs to be isolated, then you'll know that when they come to work or when there's an emergency somewhere, your client will be affected or not. That's not as bad, or that's not as urgent or as important as the fact that when your plan gets or your building gets designed on plan, that those water points are indicated to where you'd be able to find them. M says we need details on the metering of the water installation, and that includes sub-metering. A couple of local authorities who try to submit building plans and there's multiple units, they will actually inquire as to your sub-metering, because unless there was provision made, you'll find that guys will rather do application for exemption because there's no room or they didn't know about it. It is now a requirement, or it's part of the requirement, metering of the water installation. In other words, not just the bulk supply, the whole installation. So it includes the sub-metering. If the owner has to connect to the water installation to the water supply, the following details: if it's to be connected to the mains or to the communication pipe, the details of the size and type material of piping, and if the installation is connected to a water meter, the details of the size and type of outlet of that water meter. So this would be for UPVC main bolted on there, and then you carry on the other side of that water meter that goes in there. Then just a quick look at some of the notes. Items A to E and G can be obtained from the owner, and F should be determined by the design process, and H to N should be obtained from the water supply authority. So basically what we've gone through at the moment, you'll see that the owner is responsible. He'll tell you he's got the idea. He will tell you what the purpose of the building is, what type of fittings he wants to use, the schedule, how many people are going to be in there, subsoil. He bought that property, so between the designer and or the local authority and the owner, they should have that information. Quantity of water required, that would be for the designer. Sometimes a dangerous thought, but the quantity of water is there. And then the water supply authority or the local authority, municipality, whichever way you want to refer to them, water quality, pressures, flow, services, connections, metering, and size of the connection. All of that can be obtained from the Water Supply Authority. Note 2. Information required for the approval of water installations. Title deed, we're not going to worry about. Name of every street on the or the street on which the premises abut. So you'd like to know where it is. Scales of the drawings, north point, position and size of the communication pipe serving the premises, location of every water fitting and its description, location and capacity of every storage tank and water heater. Take note, water heater as well. Details of the proposed accommodation for the water meter, if it's to be installed within the premises, the pressure for which the installation has been designed, and the position of overflows. So if we do a bit of semantics and we go overflows could be discharges. Let's have a look at those. You see the smallest one right down the bottom, last but not least. If we are going to be looking at discharges, we're looking at drip trays, where the water storage heater, complete with its components, is installed in a manner and a position where any leakage from that storage water heater and its components can cause damage to the property. It shall be furnished with a drip tray. So that's what the plumber's book says. You'll find, by the way, for the guys that are taking screenshots, the bit down the side is the reference to the actual document that was taken out. So snap away. Then it says here that you're looking at the installation of a tray shall be laid to the outside, and then by the time the design is done and the owner and the architect have sat down and they've looked at this thing here, but sir, I would like exposed trusses. So they go, okay, we can do that, put a note on there, we describe it to the T, and then the plumber gets there and he goes, okay, but now I need to take a tray out. That could be boxed in like that back section. So how do I get this to the outside if that's currently being built, or that is part of the building, and this is in a proposed extension? How do you run it through there? These things need to be sorted out up front. If not, you might find that you run into one or two of these where the only way past that concrete beam was over it. We don't need any of that. This one here was, the squeeze was so tight you couldn't get it further out towards the outside, so you had to do a bit of a MacGyver to get it going back to the outside. Or if you're really in trouble and the designer goes along, you know what, it's only a 50-liter geyser, let's not bother about a tray or anything above the ceiling, and the plumber gets left with a comment like that, or this is the installation that you end up running into. It becomes the plumber's problem. And nowhere in this document the plumber has ever been mentioned once. We're getting to that still. Discharge from valves from 10254. It says that discharge pipes from expansion control and safety valves shall be of a size not less than the connection. It shall be a maximum of 4 meters, and after 4 meters you increase the total length up to a maximum of 9 meters. So if we now look at this building here, that requirement under note 2 says show the hot water cylinder. So we've shown it, or someone has shown that on this very simple drawing. Building's 22, so if we're in the middle here, that's 11 meters to the outside. There's no ways that's more than 9 meters, more than 9 meters. So somewhere along the line, when this drawing gets put in front of you, then you need to go, hold on a second. We can only have a maximum of 9 meters. Can hot water cylinder be repositioned? Yes, then move it to the right place. The note says show it on the drawing as to where it should go. Not, okay, the plumber comes to side, oh no, look here, we can't do this more than 9 meter thing. I say we move it over here. That's not your job. It's a nice, it's a handy thing to have a plumber like that on site, if he can actually advise you into which way we can make the thing work. But then by changing that design, you actually become responsible, because the client will come back in 2 weeks or 3 weeks, your geezer's up, everything's there, and he comes along and he says, but I don't want the geyser there. That's going to spoil where the kids need to play, and someone needs to move that. So unless it's in writing, if it's not written, it's not said. So unless you have a VO saying that we can deviate from this approved layout or this submitted and approved drawing, then you know you're in for a bit of moving around and chasing your own tail at your own expense, because the original design says that's where it should be, and it was never clarified after that. The Short and sweet of it is, we've looked at the requirements for building plan assessment, or the information required on the actual building plan indicating water or around the water installation. If you look at 10252 part 1, 4.1.2.2, where water supply installation is to be extended. In other words, you've got an existing system. The existing system shall be examined to ensure that it's suitable for extension. So in other words, it's not, you know what, maybe, you know, if he's a decent architect, he'll do it, or maybe we can ask the plumber while he's busy here. It says there the existing system shall be examined to ensure that it's suitable, after which the entire design shall be reassessed and modified by the designer as appropriate. Our local authority, fortunately for the plumbers in the region, I'm involved as far as the plan approval is concerned, and when you do a submission of a building plan to the Nelson Mandela Bay Metro, we actually ask for a water reticulation layout and pipe sizing. That needs to be on the drawing. I know it's not a legitimate requirement as far as residential premises are concerned. It's normally for the bigger buildings when it comes to sizing. But as far as the local authority, we require that you indicate pipe sizing, should it be upsized, the material used, all types of material available out there. So put your notes on your plan. Your client pays you to do a submission of a building plan. So put it on there and we'll assess your drawing as you submit it. Very important, or let's put it this way. One of the reasons that we deemed it important, other than giving a plumber an approved plan that says you need a 25 or a 32 mil HDPE supply from your meter out to the house, and the pipes going up in the building in 22 mil copper, or could be 1 inch or 28 millimeter multi-layer. State your case beforehand and we won't have any problems. One of the reasons that we tended to do it on all plans was that you do get buildings that change use. So when we're looking at change of use, all of a sudden Part T becomes a reality in people's lives. Here you can see, in this case, there's a half-inch supply to that hose reel at the back of this industrial building. So good luck in putting a fire out with that and persuading your insurance that that was sufficient protection. Here you've got a 22 mil polycop. So it's plastic, it's undersized, it's all kinds of things, but it won't fly. The thing around hose reels is simple. For the purpose of firefighting, they'll be installed in any building of 2 or more stories in height, or in a single story of more than 250 at a rate of 1 per 500 squares, or a part thereof, or a floor area in any story, provided that such hose reels shall not be required in H4, in other words, residential dwellings, or in an occupancy classified as H3, which are sectional title units, where each unit is provided with independent access to ground level. So if you have your own little unit in a sectional title complex and you can get out of the building, whether it be back or front, then you sort it. If it's a high-rise thing and you've got one escape passage and it is more than 2 floors high, then you'll find that that would require a hose reel. The thing is, with even if it's a ground floor like a normal house, I'm sure most of you've got areas in your or regions in your area where they've taken older houses and they've converted them into office, or guy might run a home office or a small business from what used to be a normal house before. If there's anything in storage, there's a requirement for fire protection. So if your existing system is a half-inch polycop supply from the water meter to the building, then rest assured that your fire protection is going to be insufficient. So when it states size or when it requires size, these things do play a role. The other thing that we need to look at is hydrants. It is, like I said, now if we're looking at something like a sectional title complex or something that is, I'm sure, the industrial park, permanent amusement park, or exhibition ground, shopping center, or group housing, cluster housing, or townhouse complex. Those are basically the ones that cover. And you see, once again, excluding H4, so you don't need a hydrant on your residence. The point is that if we're looking at the supply or the need for the requirement for hydrants, and you look at any building exceeding 12 meters in height, or any building of any height with a floor area exceeding 1,000 square meters, which if you're looking at these small little shopping centers or you're looking at sectional title complexes, 1,000 square meters is really not that much. Theory is a requirement for fire hydrant included in the National Building Regulations, and should you fail to have them, that's where the whole investigation into why the place burned down will start. And you can go through all this information in the document. Only thing you need to pick out here is you'll see no distance greater than 90 meters from a hydrant. So if the thing is 200 meters or 180, you need 2 hydrants in such a place where you could actually get, if they draw a circle with a 90-meter diameter, radius around that hydrant, then it should cover the whole of that area. The reason we get, or the reason I pulled in the hose reels and the hydrants, is for the very simple reason that if we go back to 10252 part 1, which is our document, pipes in any fire installation or combined installation. So you don't have to necessarily have a fire installation. It could be a combined installation. Shall be combined, being potable and fire, shall be sized accordingly to a rational design, where in any fire installation, the nominal diameter of a communication pipe serving such an installation shall be at least 75 millimeters. So if there's a fire installation or combined installation, you're looking at least 75 millimeters. A pipe supplying a fire hydrant shall also be at least 75, except where the length of that pipe exceeds 50 meters. The nominal diameter of that reticulation shall be 100 millimeters. That is for the premises. So once you've got an incoming main of whether it be 75 or 100 millimeters in diameter, we now move into the building, and it says a service pipe supplying the water to a hose reel on any one story of a building. So you have to picture multiple stories, or you're looking, say, let's call it 2 or 3 stories high. It's in excess of the 1,000 square meter limit or allowance that was made. So now we need to know per story. Once again, for the guys that haven't attended the water one, this is how you cheat on it. You see the 2 from 25 says 1 or 2. The 3 says 3 hose reels. The 4 says 4 or 5, and the 5 says 5 or more. So if on that one floor you have got 4 or 5 hose reels, you need 40 millimeter of water supply to those fire hose reels on that story, or per that story that you're busy with. Then the next one's got maybe 2, depending on the layout, or 3 or 4. Then you go, and on each of those levels, the pipe sizing will be done 25 for 2, 3, 40, 50, depending on the requirement. Most definitely not like this example here. This would be plastic, it would be undersized, it would be wrong on so many levels that it's actually scary. Can you imagine a big building or an industrial building, fire starting somewhere, and someone's got to run to connect the hose onto this, and you've got this little 25, or even if you're lucky, I think if I remember correctly, that might have been a 32 mil HDPE, which gives you about a 1-inch internal. So you're looking at 1 or 2 hose reels, never mind a 75 millimeter hydrant that needs a 75 millimeter supply. So before we move on to the drainage bit, have we got any questions?
Yes, John, we do have questions. The first one, does a hose reel require a separate line running from the mains, or can you tap off the closest entry into feed line to building?
Okay, there's actually a multiple answers to that. Yes, they used to have separate metered connections for fire, which then later became a single connection because the guys had the unmetered fire water was being used to wash trucks and clean out the yard and clean paving and all the rest of that. So it became a metered installation. You do have combined installations where you have fire and combined supply on the same incoming main with its own set of rules. The most important one, I think, is the fact that you can't use anything plastic on that incoming line. if it's going to be a combined installation, which we'll be doing a tech talk about in the next couple of weeks. On that combined installation, metal only. No PVC or plastic or polyolefin, if you want to use the combination or the combined name for the group name of the whole lot of plastics put together. None of those above ground in a combined installation.
Okay, the next one. On an approved plan, digging for sewer main connections and is not found on the approved plan indication. What is the procedure as your trenches are now open and connection points is incorrect on the approved plan? It's costly, time consuming, etc. Who do you approach regarding all the extras for the costly inconvenience as you might only have a digger booked for that day?
That is a very good question, which we'll be touching on in about, I think, 4 or 5 slides. But basically, if the plan was approved by the local authority, that means that there's a, I'll tell you now about the connection points. But yes, it's not only a nuisance, it's a pain in the butt. You've set out this whole digging process, you've done what was required, and then you get there and there's nothing. So yes, there's a procedure where you can contact them and they'll come and install it, but we'll talk about that now when we get to the drainage.
Okay, when are vacuum breakers required by each reel?
Are we talking vacuum breakers being at the highest point of that water supply on a fire installation only? Then that would be part of backflow. Let me just make a note here. I'll find that quickly. Okay.
All right,
I'm
the
sure
next one.
that's the question, and that would be the part of the backflow when it's a high-rise building.
Okay. The next one. I was failed by a building inspector for using copper between the shuttle valve and reel. Is this correct?
Between the shuttle valve and the reel, you'll find that if I remember correctly, there's a, if you're using a, sorry, let me just get back to my, that would be the arrangement. You have a union between the hose reel and then you have that specific fire stop tap. It's not a ball cock or ball valve. It's one of these slow turning taps here. That is the accepted practice when it comes to installing a fire hose reel. Trying to think why I would have failed the copper, but that as far as I can remember, that is a standard connection for a fire hose reel. We are going to get those questions on an email, are we, Jock?
Yes, we are.
Okay, then I'll follow up with that gentleman. But that, as far as I know, is what a service core connection to a fire hose reel looks like.
Right, the next one. Is non-return allowed on fire?
It's not only allowed, it's compulsory. The standard says that any connection between potable water and fire water shall have backflow prevention. So depending on the position and the actual layout, you'll find that most of the time where the potable and fire supply split, that is where your backflow prevention is, so that if the old Dennis gets there and he applies extra pressure or that filthy water in that fire system, we don't want that coming into contact with a connection of potable water. So yes, most definitely it's a requirement.
If the metered outlet is too small, do you therefore have to contact municipality to change the meter accordingly so that you may have a sufficient supply of both fire and usage?
Yes, it's part of the plan approval process. You'll find that there are, I know eThekwini's got water inspectors. We've got a couple of guys that do these plan assessments for the water net. If you motivate or you indicate on your plan why you would need a bigger water meter, they'll work out a cost and they would come and do the installation of that upsized meter. So yes, that's the theory.
Can a fire main be part plastic if below ground?
Yes, look, you do get UPVC mains underground. And then when they branch off, the standard says that anything above ground can't be plastic. So if it's UPVC underground, By the time the soil is heated up enough to melt that PVC pipe, I think there'd be nothing left of the building. So yes, if it's underground, and definitely underground, I'm not talking about under the surface, or maybe there's a changeover between the metal and the plastic. I'm talking about underground. That would be acceptable, but anything above ground needs to be metallic.
Okay, must have union couplings either side of stopcock by reel.
Yes, there's a union between a reel net, or you could have a compression type fitting on the at the other end. Yes, but you need to be able to service, or you need to be able to remove said stop tap. But the main thing is that if you need to service the hose reel, or you need to work on the reel, that you do have that union on the top there to make sure you can remove it.
Are you not supposed to have a pressure gauge on every fire reel?
Now, not each reel. You can have one on your supply, on that fire supply, to make sure that it, especially the bigger ones, if you have the ones with those jockeys and gongs, and you have a little service room with the valves and the non-return and all that, as long as you can maintain, or as long as you can ensure that the pressure in that main is above the minimum requirement, then you will look at that specific gauge. But each of them don't require one.
Okay, new build complex, you come across no water meters. How do you approach the developer?
You approach him by quoting legislation. Um, that same in 2001, there was a document that was published stating that every building in separate occupation, albeit a group housing or sectional title units, all of them need to comply with the provision of water meters to each and every unit. Um, when I get that email, I'll attach that extract from that regulation that was published. I think it's 8, if I remember correctly, but it was in June 2001. The section actually starts by saying, after the promulgation of this regulation, every building shall, and then they list all the requirements as far as the individual units. Even if you're working on like an industrial complex or something where you have individual units, every single one in separate occupation shall have a water meter so that you can monitor consumption, see if there's any underground leaks. But most definitely that standard requires every building in separate occupation, homeowners, in other words, being either like a hybrid subdivision, or whether it's a sectional title, apartment building, or flats, anything like that that have got permanent occupants in them, you need to meter them separately.
Okay. Can the fire main below ground be HDP?
If the rating is if the rating is suitable, I'm sure it can be. Like I said, as long as we're talking underground, I need to make sure that there's no misunderstanding. If it's underground, we're talking we're talking civils. When we're talking plumbing, that's metallic. Anything that pops out the ground, or any point where it enters the building, is metallic. Then below ground, the standard does not refer. All you need to do is, when you're looking at the material, it says suitable for its application or suitable for use, and it's got the correct pressure rating. I'm sure it'll be acceptable as long as you stick to the metallic above ground. Okay.
Yes, that is all questions for now. Thank you.
Okay, so let's dip into drainage quickly. When we're looking at drainage, the building control officer looks at drainage completely differently to what they do to water, because Part P is part of what they should be enforcing. So I only put your National Building Regulations. It should be National Building Regulations and Standards Act, blah, blah, blah. But for short, NBR P2. And listen to these following requirements, and then you think about how many drawings you see that do not have them indicated. We'll go through them all, but just quickly. Any drainage installation in any building shall be designed and constructed that there's an adequate number of sanitary fixtures is provided in relation to the population and class of occupancy of that building. Yet we still have people standing in queues in public buildings trying to get to a toilet. Such an installation is capable of carrying the designed hydraulic load. Such an installation is capable of discharging into any common drain, connecting sewer, or sewer provided to accept such a drainage or such a discharge. All components and material used in an installation is watertight. No nuisance or danger to health will be caused as a result of the operation of any such an installation, and any drain in that system is of such a strength, having regard to the manner in which it's bedded or supported, that's capable of sustaining the actions to which it may normally be subjected, and that is, where necessary, protected against drainage. All sanitary fixtures are located that they are easily accessible to those persons they intend to serve. In other words, if you do have a paraplegic or toilet for people with disabilities and it's on the first or second story and there are only staircases, that basically means nothing. It's a stupid example, but yes, that would be part of what that point is. Any necessary inspection, cleaning, and maintenance required may be performed through means of access provided. So it's not a, you know what, it spoils the elevation of the building. P2, which comes from the building regulation, says that when you design a drainage installation, any necessary inspection, cleaning, and maintenance required may be performed through means of access provided. Then, this is P21. P22 is the kick in the gut for most of the designers that are not qualified. The requirements of sub-regulation 1, in other words, what we just looked at, shall be deemed to satisfy where that installation complies with SANS 10400 Part P. Take note, it says SANS 10400 Part P. In other words, the whole document. You can't pick and choose, I'd like for this to do and I'd like for that to happen. You either comply with the whole thing or something else. Provided that where a local authority is of the opinion that the size or the complexity of that installation in any building renders it essential for that installation to be subject of an approved rational design prepared by an approved competent person, that local authority in writing notify the owner of that building of its reasons for the necessity of that design, for such a design, and may require such an owner to submit for approval plans and particulars of a complete drainage installation based on such a design. In writing, I can tell you already the surefire way to do that is you file the applicant's plan, and once that plan is deferred and the comment on there says drainage not approved, engineer's drawings required, or competent drawing from competent person, that is in writing. So the client will be notified and they will get back to a rational design a bit later. Like I said, 10400 is the BCO's Bible. That's what they claim to operate from. So if we start with part A, an application, the designing, planning, and supervision of the erection of any building or structure or the performance of any function in connection therewith in terms of these regulations is subject to the provision that the person undertaking such work or performing such function is required to be registered. Take note. So the guy that's doing the designing and the submission of the building plans to council shall be registered in terms of the Architectural Professional Act, Engineering Profession Act, Natural Scientific Professional Act, Professional and Technical Surveyors Act, or any other relevant act. It does not include plumbers. It does not say, nowhere, it doesn't mention boermakeplan. It doesn't say, you know what, I was in a tight spot, I had an afternoon to do it before the tiler or the guys putting concrete down came in here. It needs to be done by those professionals taking responsibility for that. A2 says that any person intending to erect a building shall submit to the local authority the following plans and particulars together with the application. Site plan, we need to know what we're doing or where we're heading on site. Layout drawings, in other words, what do those bathrooms look like, where are the toilets, where are the ducts. Drainage installation drawing, good heavens, can you believe that? SANS 10400 Part A. A2 says you need to submit a drainage installation drawing. How many of you have seen that? Plans, drawings, and diagrams shall be of suitable scale selected from one of the following. See, site plan, we know we need that, so that they can give us in any scale. The local authority may accept a scale not provided for, depending on what the designer did or how big the sheet is that they're submitting, whatever. The point is, site plan, we need plumbing installation drawings. Wow. We don't see those too often. The book says, shall be drawn to that scale. You need to submit that. To make matters worse, 1 copy of the plan and drawings contemplated for the convenience of the local authority. Identify in a suitable manner or color the following as indicated below. They even need to color and highlight the points that we're working on. Drains, waste pipes, soil and vent. See all these colors? They're all related to plumbing. So one of those sets of drawings needs to be colored to the point that if it's there or it's not highlighted or it's not clear, then you could ask for the one that was actually required for the submission. So it's not, you know what, Mr. Plumber, you're being difficult, or Mr. Plumber, you know what, we'll get back to you or whatever. It's part of the BCO's Bible that they refer to all the time. It's just a necessity for them to pull it out there. But those are just for the drawings. Let's look at the actual plan submission. Any drawing of a drainage installation as contemplated in Regulation A2 shall contain as many plans, sections, and elevations as may be necessary to show where relevant the following. You'll find that depending on where you submit in the country, plans, obviously the floor plans and the layout section through the building. In other words, you cut away the building to a degree where you can actually see if the thing's got to be suspended under the floor, that there's enough headspace. Elevations being there's plumbing on elevations as well, so you can show the position of the stacks, where they end up going past the windows, around the windows. We'll get to all of those. But the point is, they shall contain as many plans, sections, and elevations as may be necessary to show. So we get back to the question that we had earlier. This would be the first requirement. The location, size, and gradient of any drain and connecting point to that drain in relation to a datum established on the site and the level of the ground relative thereto. You might get them in different shapes and sizes. Basically what I've done is, you see the darker black lines, those are the boundary lines. So on A, you'll find that if you're looking at the dimension of A, that would be from the boundary, being lateral or front or whichever way the sewer is running. You'll see there's the boundary. So A would be how far you are off that side or lateral boundary. And you'll go through all of these and you get to F at one there. Ground level is GLC is ground level at the connection and the invert level of the connection. So they give you a value, 1.2 meters, 1.5, 3 meters, whatever. You've dug on that at that specific point, ground level minus invert level there. And then the important one as far as design is concerned, you'll see invert level connection, invert level sewer. So there's the connection point and there's the sewer. You won't go in more than half pipe on a connection, because you leave the channel or you leave the invert of the pipe clean for uninterrupted flow. If that thing says 0 or 100 mil or 200 mil, 500 mil, that's here, then you know lowering that connection to accommodate a longer drain or taking it around the building twice before you come back is never going to happen. But if the difference between the connection at the connection point and the sewer is 3 meters or 4 meters, that means you can actually apply to have that lower to the point where you require it. So basically, if you have an approved plan which a municipality is approved and it says that connection point is 1.3, which is pretty standard across from the boundary, and you've got a municipal servitude of 2.6 or 3, and you are left 1 meter outside. So if you're 4 meters out and 1.5 meters from the side and it's not there, you contact the local authority. And I can tell you that they probably won't fix it. They will go back to the designer and the guy that did the civils work when they installed those municipal services, and they'll refer to earth number X, Y, and Z, or 1, 2, 3, and those guys will go back and they'll expose that main to see where that connection point is. If it's not there, they'll install it. So basically all you need to do is get back to your local authority. You get two types of connections. You either have a sorted out main, in other words, you have a reticulation that goes through the property, and they never put the connection points because they left it up to the developer to see, or the designer of the building, where they would like that. That's called an order connection. So you order that connection, you'll pay for it, and they'll install it. If it's a locate connection, you'll probably find it's one of those that have been installed up front, and that'll be to the lower side. In other words, the way the ground and the sewer falls, it'll always be on the lower side to accommodate maximum fall on that pipe there. I hope that answers that gentleman's question. B says you need to show the location of any point of access to the interior of the drain. Yeah, there's about 10 or 12 different places. This 1 hour session is too short for that. You'll have to have a look at one of the drainage webinars. What I can tell you is that there are 4 types basically referred to in these drawings. An inspection chamber, it's not a fancy name for a manhole. An inspection chamber is a chamber not deeper than 1200 mils, and the dimensions that access can be obtained to a drain without requiring a person to enter that chamber. In other words, if you need to get a drain rod in there to change or to clean up a pipe or to gain access to the interior of a drain, not less than, or sorry, not deeper than 1200 millimeters, and you don't need to get into it. An IE is there for purposes of inspection and testing, and to which permanent access after completion of the drainage installation need not be provided. So when it comes to permanent access, years ago we used to have IE junctions on gullies, so that if you couldn't clean the gully properly, you ended up finding that IE, and you open that, you could then get access back towards the gully first of all, and into that line from that IE. But there's no permanent access. You actually have to dig it open to find it. A manhole, sister of an inspection chamber of a great depth greater than 750, and the dimensions is such that it allows the entry of a person into that chamber for the purpose of providing access. So normal 1050 ring would be a perfect example. You slip the cover off, you can actually get in there, get to the bottom of it safely. There are health and safety requirements into working on these bigger pipes, but that wouldn't be applicable on residential properties. A rodding eye, access to a drainage installation provided for the purpose of gaining full bore access to the interior of a drain for cleaning, and which remains permanently accessible after the completion, but does not include an inspection chamber or manhole. So one of these 4 will be on that drawing, indicating exactly where and how you'll be able to get access. It's not, you know what, Mr. Plummer, do what you think is necessary to get past the council or the municipal inspector or the the IOPSA compliance auditor. It's down to making sure that the requirement is that you will show those location of those access points on the drawing. C says the location of any trapped gully. Simple. Same building. Got a gully at this level here, so that is your flood level or your overflow protection level is up here. That means that if this pipe running down here blocks for some or the other reason, whether it be the municipal reticulation or whether it be the internal drainage, or lo and behold, that could be the council main with a connection out here onto the property. If something goes wrong, this becomes the flood level. In other words, the water would pour out of this area or around this area long before it hits the building. So now the client says to you, but hold on a second, I don't want that smelly thing in front of my kitchen here or whatever. We take that waste pipe from that sink and we put it in the stub sack and we reposition the gully. So now you look at that old drawing and you see, but hold on, nothing has changed that much. We're just moving the gully, but what you're doing in reality is you're taking that overflow point and you're putting that the highest point, because remember, this thing will go up and up. So anything below that is going to be under threat. So before the water comes out of that precast top on that gully there, those nice walk-in showers and bath traps and all these lower fittings are actually exposed. So by the time the water pours out here, and it does, we'll see now, your house will be flooded on the inside. Put that in plumber's terms, that's what an overflow gully should do. Anything goes wrong, it spills outside here and it runs away from the house. This was from a municipal sewer backing up, no gully or no overflow protection. So you can see when it runs, it pours. Same thing applies here. Showers on the other side of this setup here, no protection. So those showers will just keep filling up and filling, or the water from the outside will just keep filling up. Here's a normal residence. Gully was higher than the shower on the inside there. Here you can see drain blocked and it ended up bubbling in through the house there. So that's what happens if you don't have a gully that is compliant, or the installation of a gully that's compliant. The location details of any septic tank, conservancy tank, private sewage treatment plant or sewage pump. Need to show those on site, where you're working to, Conservancy being the one that they empty out, and a septic tank, you need to make sure that the soakaway and the position of the tank and that comply. And then on-site treatment works or pumps or anything in that regard, need to know where they are and what they're doing. The guys that do work in the rural areas, location of any percolation test holes excavated on the site of any French drain. Simple reason. Okay, let's put it this way. It sounds simple enough. The problem is that you could have a triple-story building approved on a farm where this guy wants to put up a hunting lodge and what have you not. Fact of the matter is, you get there, you start the drainage, you work yourself up to the point where the soakaway is going to be, and then you go, hold on a second, this thing was supposed to have been tested. That little cube dug at the bottom of the trench would have been filled with water, and the rates of application, if it takes longer than 30 minutes, it's not permitted. And if it sits up here and it goes to, let's call it 27 to 30 minutes, which is basically almost nothing, then you're looking at 39 to 33 liters per square meter of drain trench size. There's a calculation in 10252 part 2 and 10400 part B that explains to you the surface area of that trench is where the water soaks out there. So the point is that if you are going to have to dig a trench, someone needed to make sure beforehand that you don't end up in clay or a rock where you don't have enough percolation rate to actually make this tank work. The location and arrangement of any sanitary fixture served by that drainage installation. Now these two are the exact opposite of each other. So here we can see a bigger, fancier design. So you've got a three nice plumbing ducts. You've got access to those ducts to work in. Access there, and we've got access there. So you'll pick up all of these toilets will either be into stacks here, and that drain could go from here to the outside, or it can go from duct to duct to duct and then go out, or then go out of the building. You've got all the fittings shown. You see these will go through the wall. That's not a problem. This will go into this duct. Everything backs onto a duct. Very nice, easy job. Chop a hole through the wall, you're into that duct. That's where the drainage happens. And then you look at this one. And you look at the plan and you go, okay, location and arrangement. Wow. How would you get that? Where would you take that? If that's a wall, how would you get access to these toilets? Where would these showers go? How would you get these urinals back into something over there? These basins, how would you get them across the floor to? So when you look at these two layouts, I mean that this one here, you actually feel like going to fetch your toolbox and your fittings and that we can get going on this one. This one, you need to look at it and you go, okay, maybe I should just leave that to that bloke. I don't like that much. He could rather do that job, because this is going to, and the problem is if it starts like this, it's only going to get worse, because once you start with that, oh, don't worry, we'll sort it out, or how does that thing go, hold on to my beer, I'll show you. You start off with that attitude on a job, then you know that this one here, you'll probably get signed off easiest by. This is going to take some serious doing it yourself. Location and size of any soil pipe, waste pipe, and ventilating pipe or device. So here you can see by the time this concrete is cast, you'll have 1, 2 toilets in the slab. Disappearing into the slab, you can't find them. These waste pipes you can't get access to. They'll be dropping down into the slab somewhere. So if it's indicated like that, or there's a change of direction in or around a slab, anything like that, you'll probably find that this building plan, if it was submitted as being done here, would have been failed at submission stage. The location of all openings in the building, such as chimneys, skylights, doors, windows, ventilating openings, and air intakes, which could permit the entry of foul air or gas into the building from any ventilating pipe or device. Personal opinion, guys, it's happening out there. I don't know why they put this in here, because even if that guy shows a stack going, whatever, you'll find that, I don't know where the plumbers actually aim for those windows, but you'll find a whole lot of time, or a whole lot of sites where that little puff pipe or that little 50 vent valve is right under the window. And if you're not really going to be cheap and you don't have to put a vent valve, why don't you just leave a vent cowl right under the window so that the whole neighborhood can vent into your client's property? So that's something that's a requirement, and it happens far less than what it should, but yes, it is a requirement that needs to be sorted out at plan submission stage. Please, no hiding in the cavities. No, my client doesn't want to see the pipe. I'll put a two-way. Well, you even get the wonderful designers running on one-way vent valves. There is no such a thing. Two-way vent valve, the same rules that apply to this open vent applies to a two-way vent valve. So if the design comes up, well, my client doesn't want to see that, then you know you're in for an argument or you're in for a negotiation towards the end of that property. The location of any well, borehole, or water course on site, for obvious reasons. You're at a 1.8 meter maximum soak away, and you might have a borehole or a well on that same premises. We do not want any of this water contaminating the groundwater, and then you end up starting your own recycling plant on the site without you even knowing it. So we say minimum 50, ideally 50. That was the report done by Water Research Council way back when. I'm sure there'll be more scientific ways of doing it, but the fact is that if your 50 meters minimum, anything more than 50 sounds like a bargain. The fact is that, like I say, if it's not shown, if the water or the borehole is not shown on site and the plumber walks onto site, we've had a case in Port Elizabeth where the two small holdings out on the farms, they sued each other because the one guy polluted the other guy's water, and the architect never realized there was a borehole on the other side of the fence. Local authority may require the following: drainage design. This is for effluent. So you'll see on these designs, there'll be a design on how they'll treat it or how they'll discharge of that into a pond or a holding area. Anything that then deviates from that design becomes that owner's problem. So if you do it according to the drawing, if they then do not maintain it or they stuff it up somewhere along the line in their maintenance and their cleaning up processes, then it's not the plumber's concern. As long as it was done to that plan and particulars of that drainage work. If it was done accordingly, you're safe. We're almost there, guys. I see it's past 2 already, but we're almost there. This schedule, or this form 1, is from 10.400 Part A. The municipality will not accept a building plan submission without this form ticked, signed off by the professional at submission stage. So this is basically what it says. Building classification, H4, you're doing a dwelling. That professional's only got 3 choices. They're either going to say that Part B, yes, we comply with the detailed requirements of SANS 10.400 Part P. In other words, whatever Part P says we're complying with, that would be first up. Second option is the subject of a rational design or a rational assessment, or both. So you could then appoint a competent person to actually do that. Or you could be, or it could be, the subject of an agreement certificate. Those are the 3 options left to that professional, a means by which the regulation is to be satisfied. So AZ4, we'll have a look at now. These are the 3 options. If it's not on that list, you shouldn't even be submitting, because if this not ticked yes, yes, or yes, one of those 3 options, that means that the system cannot comply. Then heading towards AZ4, the functional regulation contained in Part P shall be deemed to satisfy whether the drainage installation complies with the requirements 4.2 to 4.27. 4.27 is the testing of above ground soil and vent. 26 is drainage, and you can work your way 4.2. All of those requirements apply. So if you skip on one, you can't have 4.2, 4.9, and 4.13 because they suit you and you skip the rest. It's either going to be all of that, or it's going to be the subject of a rational design performed by a competent person, sanitation, which I can tell you by definition is only a wet services engineer, and using the principles for the design, installation, and testing of sanitary drainage contained in this part of 10.400, or an agreement certificate. Agreement certificate, in short, is a certificate applied for by a manufacturer for a non-standardized product. In other words, there is no SABS standard for, or SANS spec, that they can have your product tested. So what they do is they take all of this with test reports and papers and body of evidence to the national regulator, and they say, yeah, we've got this beautiful system. It'll turn sewage into Coca-Cola, whatever. This is how it works. This is how we put it together, and this is how they do it. And they test it, and then they get issued a certificate or an agreement certificate. The problem with an agreement certificate is that if that certificate requires installation and assembly to be done 1, 2, 3, 4, 5, and you do 1, 2, 5, and you skip 3, or you skip 3 and 4, that whole system becomes null and void. That certificate only applies to that product if it's installed exactly word for word as per that certificate or that um, design that was done at the initial stage. An agreement certificate is an option, but it's a very I wouldn't say difficult option, but it's a very complicated option. Okay. As far as plumbers on site are concerned and plan approvals concerned, a competent person who's registered in a category in terms of Architectural Professional Act, Engineering Professional Act, Sciences Act, or any other relevant act in accordance with the requirement of A19 shall prepare and submit to the local authority a rational design or rational assessment where compliance with the requirements is to be satisfied. So this is what we just looked at those different options that you do have. So if this design is going to be dependent on a rational, or this design is going to be something done by a competent person and it needs to comply with that building solution, that's easy enough. The guy can do his submission to council, they'll approve it, they'll do all of the rest of that. As far as the plumber is concerned, by the time you have that design, you do the job accordingly. You see that there's something contrary to that, like I said, if it, like we did with that TAC resolution, if you notify your client or the professional upfront in writing that there's a problem with his design and it's contrary to these regulations, then basically you started off right and you've got yourself covered to a degree. Then the council will then approve this. You had your say, or it wasn't necessary to do that. At the end of this whole process, an approved competent person who did this design in respect of a system, measure, facility, parameter, or installation shall inspect and certify. In other words, no, Mr. Plumber, you the plumber on site, you sign the COC. The guy that did the design shall inspect and certify upon completion in accordance with the requirements of the construction, erection, or installation thereof. So when we're looking at AZ4, you're looking at a rational design, and there are plenty around. Any fire installation according to 10252 is a rational design. You're looking at drainage as too shallow or too little fall or too much volume or too much of whatever is the problem area. You can have a rational design done according to 10252 part 2. 10254 says if you cannot comply with any provision in the standard, a rational design, this by the way is a rational design, anything suspended from a slab as far as cylinders and tanks are concerned is a rational design. Here we're looking at 10.10.6 says design assessments by a competent person when we're looking at roofing and where you're putting these things up here. Before installation, an assessment will be done by a competent person. So that is also a requirement. And then something that came up about 2 or 3 weeks ago in the same national building regulations. We just need to read this here. It says exemption from liability. No approval, permission, report, certificate, or act granted, issued or performed in terms of this act by or on behalf of a local authority or in the council in connection with the design, erection, demolition, alteration shall have the effect. Okay. Me, remember I'm an Afrikaans farm boy from Oudtshoorn, so let's skip all of these fancy legal little bits and pieces, and we see that no approval, in other words, your plan gets approved or your client's plan gets approved, no approval, whether it be the council or whichever way you want to go, this shall have the effect that that local authority or the council become liable for any persons, loss, damage, injury, or death resulting or arising out of or in any way connected to the manner in which that building was designed. Okay, so that puts the designer at his own risk. So the council is exempted from any liability. Then we read further and it says here, no approval shall have the effect of the quality of the workmanship in that erection, demolition, or alteration. So the workmanship in that, I know some of the local authorities have submitted plans before. They'll tell you your building plan is approved subject to compliance with building regulations, and they give you a whole list of regulations. So basically, as far as the building regs are concerned, the local authority is not going to accept responsibility. They are telling you that no approval shall have the effect that they are held liable for the quality of workmanship. Then it says here, the owner of that building, no approval shall have the effect that the owner of that building be exempted from the duty to take care and to ensure that such a building is designed, erected, completed, occupied, and used, or demolished and altered in accordance with the provisions of this Act or any other applicable law. If you find a client like that, please pass him on to me. I'd love to work for them. There's no ways that the owner of a building is going to take care and ensure that the building is designed. That's why they went to the architect in the first place. Erected, they went to a building contractor, completed, occupied, or used, or demolished, or altered in accordance with this Act. They don't even know that the National Building Regulations Act is there, or any other applicable law, which then covers our Water Services Act and all the other installation standards and. Then you're looking at the last one, says no approval shall have the effect that any person be exempted from the provisions of any other law applicable in the area of jurisdiction of the local authority. So if they run out of explicits or they run out of explanatory phrases here, then please do realize that by the time you get to see that it says here from provisions of any other law within the jurisdiction of the local authority. And most of those local authority bylaws have 10252 Part 1 and all of those documents as part of their installation standards, or it's referred to or referenced in that document. So good luck in getting past that. So even if there's a mistake, what I'm saying to you is that this, whether the permission's been granted, the report's been done, a certificate or act granted. In other words, even once the municipality has approved the plan, the responsibility is still with the people involved in the project and the actual owner to make sure that they comply. And then any other person involved with that would be covered in there or under these different laws. So if your client is there to make sure that the building complies and any other applicable laws, I'll tell you what, the first thing they'll pull out is they'll pull out the same document, or their lawyer will pull out the same document that says here that firstly, no person shall perform the trade of plumbing. In other words, you are qualified or competent. That's why I appointed you. That's why I'm paying you the good money so that you can provide me with a product at the end. We're going to skip through all of these other legals because you shouldn't be doing plumbing if you're not qualified. And then the other edge of that double-edged sword says any trained plumber who causes or permits any person who is not a trained plumber or is not a person contemplated in sub-regulation 2, which is basically that old man clause, to practice the trade of plumbing without adequately controlling the work done by such a person shall be guilty of an offense. And we know that adequately controls means that the work is done up to the point where it actually complies with the legislation. So that is as quickly as what I could get through water and drainage approvals as far as the planning or the plans being submitted to a council is concerned. Have we got any more questions?
I just wanted to say thank you, and then thank you, ladies and gentlemen, for joining us. As Adrian said.